Hi, everybody, and welcome back. Today, we're going to look at how to use conditional statements. You know what they are. They're the if-then statement, the case statement, the in or the not-in statement. Let's go ahead and get started. But first, just a little bit about me. Some of you may be new out here. My name's Jim Dehner. I'm a three-time visionary, seven-time Forum ambassador. I co-lead the newbie user group and also the Nashville Tug. Now, today, what we're going to do is we're going to talk about conditional statements. And all of them have one thing in common. There's a test condition. There's some sort of test that returns a Boolean. And if it's true, there's a statement that's executed, so-called if then. If this is true, then execute that statement. If it's not, then move on to the next record and continue checking each record individually. Conditional statements are done at the record level, and that's really important to know. They're not done overall, but they're done record by record as you go through the data. Now, uh, the data set we're going to use today is the same data set I always use. It's a data set you got when you got your copy of Tableau. It's a Superstore data set. You can reproduce anything that we go over here with that data set. You can use it to compare your answers with what you'd expect the answers to be. And I just like to take a look at sales, and we're going to be taking a look at region and categories by year for a while. Well, let's take a look at what an if statement will do. I want to start with some very simple if statements. The first one is we're going to take a look at a statement that looks like this. And this is what the syntax looks like for an if-then statement. The keyword is if, and then this is the test. And here we have category. Category is a dimension, and it is a string. Okay. And my test is if category equals furniture, and this has to be an exact match, then sales, else zero. And you can see here in the first half of this chart, that's exactly what this table returns. Anytime we have the category equals furniture, we record the sales, but anything else, we're recording a zero. And that's pretty straightforward. I want to go to the next level now, and we'll go to the this is the statement we just started with. If category equals furniture, then sales. Well, what if we had another condition we wanted to check? We add that condition in with an else if statement. And that's all one word, else if region equals east, then zero. Okay, so this statement is going to look, and it's going to look at each record. And if the category equals furniture, then it's going to equal sales, and then it's going to return the sales. And then it's going to go on to the next record, and it's going to check the next record. So if we have a condition where a record and the category does not equal furniture, then it's going to check to see if the region equals east. And if it does, it's going to return a zero. And if neither of those conditions are met, then it's going to return a null. And that's what we see going on here. We see here all the furniture categories, we've recorded the sales. In the east, in the region equals east, first, we check the category equals furniture, and for these records, we record the sales. For all other records in the east, we've returned to zero, and everywhere that the category is not furniture and the region is not east, we return a null. And that's how a if-then statement works. And you have to keep this in mind that if you have a series of else-if statements, Tableau is going to check each record starting at the first test condition that you've got, and then proceed to the next and proceed to the next. But what it will do, as soon as it finds a true, it's going to execute the then clause and then go on to the next record. And that does cause some confusion with some users. Well, let's go on and take a look at some of the things we can do with if-then statements. Here I want to use them to create groups, and you may have tried this yourself. You said, well, look, I want to produce bins, but I don't want my bins to be equal size. So I have to have some custom groups to create those bins. And hang on just a second while I find the right one here. Okay. And we write a statement that looks like this. And here we've got those multiple categories, if you will, the multiple else if statements. First, we're going to check to see if the sum of sales is less than 10,000, then I'm going to put a label on it called less than 10,000. Now, if that's not the case, else if the sum of sales is less than 20,000, then the category is going to be called 10,000 to 20,000. Else if it's less than 30,000, it's 30K to 40K. Else if it's less than 40,000, 30 to 40K. Else and everything else gets thrown in a category called greater than 40,000. Now, there's a couple things to notice here. I've done this in numerical order, sequential order, if you will. We start by looking at all the records are less than 10,000. So now if a record is more than 10,000, this test is going to return a false. The Tableau is going to go on to this test. And it's going to take a look at that record, and it's going to take a look at the sum of sales. And if it's less than 20,000, we know it's greater than 10,000. We don't have to check the lower end again. We've already checked it. We only have to check the upper end. So we know it's it's greater than 10,000. Now, is it less than 20? If it is, it falls into the second bucket. And if it's not, then we check the third bucket, see if it's less than 30,000, and so on. And doing that, we're able to create these buckets that you see here, less than 10,000, 10 to 20, 20 to 30, 30 to 40, and greater than 40,000. And that's how you would create custom buckets to use in a bin. And you can use that to create a histogram, or you can use it in other calculations also. Now, I want to go into an additional concept here, and that's the concept of taking two statements, two if statements, if you will, and joining them together, connecting them together with a logical connector. And those logical connectors are and there's also or. And you can put a not and a not or. But we're going to focus today just on and or. And we're going to take a look at this very simple calculation and how this might look. We're going to take a look here. We're going to say, well, this first one, using an and connection, is I want to look at records where the category is furniture and the order date, the year of the order date equals 2022, and I want the sales for those, and everything else I want to return a null. Now, it's important that both of these conditions have to be met at the same time. I have to have the furniture, I have to have the category equal to furniture, and I have to have the year of the order date equal to 2022. Anything else is going to return a null. And that's what you see here in this section of the block. The only record that qualifies is this record here, year 2022, in furniture category. We could also look at the or statement and the same general format, except we're taking a look at the category equals furniture or the year of order date equals 2022. Then I want to see the sales. So if either of these conditions is met, the category is furniture or the year equals 2022, I want to see the sales. And that can print this block here. I can look at the category equals furniture, or I can look at those that qualify under year of 2020, 2022. Now, it's important to understand the difference between and or, and you might have already figured out that, yeah, I can chain these conditions together. I can have several and conditions and an or condition. And in that case, if you wanted to chain a few and conditions together, you'd embody the entire group in a set of parentheses, followed by an or, and then another set of parentheses for the second set of conditions that you're looking at. Then we'll look at some of those things along the way. Okay. Well, pretty much by now we've been looking at using a string category, a string as our test condition. We can also use date conditions, and I want to show you how to use an if then type statement to calculate year over year sales and do a variance on year over year sales. It's one of my favorite calculations because very often users will come back and will say, well, I want to be able to do year over year sales, and I keep getting back with, I keep coming back with nulls in the data set, and it doesn't work right. I don't get the right number. And that's because they're filtering out data and they filter out 1 year and they don't have data for both years. So I suggest that what they need to do is they need to take and create an LOD expression. And the first thing I did is I calculated the last date in the data set. You have to have a fixed position to do this, a fixed end condition. And I just used the last date in the data set. And this is what's known as a table LOD. And what this calculation does is it looks at the entire data table for this worksheet, and it returns the max order date for that LOD. I could have used today. I could have set up a parameter so the user could choose the last day that they want to look at. And I'm going to use this max order date to calculate the month over month based on this last date. Now, in this case, what we want to look at is the last completed month. We've had users ask this question before. I'm in the middle of the month, and today I don't want the month to date in, on the 12th day of November. I want the last full month we have. I want to compare all of October to all of September. They want the last completed month. So what I've done here is I've taken a look at embodying and putting a if-then statement inside an LOD. And this is the way it's done. I've seen people try to take this and they'll put the if-then statement outside the LOD, and it doesn't work. You embody the if-then statement in the LOD expression. And all this statement does is it says if the it's going to be fixed at the category level. So I'm going to look at each category individually. And here's our if statement and our then statement. Here's the if then statement right here. And we're going to put that after the colon in the LOD expression. And all this expression does is it says if the month of the if the month of the last date. So let's start with the innermost part of it. I use this date add expression to look at last month. I take a look at the last date in the data set minus 1 month. That's what data add will do. Data add takes a look at minus 1 month from the last date in the data set. And date trunc will look at the first day of the month. In our case, it's going to look at the first day of the month prior to the last date in the data set. And if that is equal to the first date of the month for the order date, then record the sale. And that's what the if-then statement does. That's all it does. It tests this condition, and if that condition is true, it returns the sales. We have to aggregate that. So we embody that whole expression in sum, right there, and our LOD is complete. Okay, and that's going to return the last date in the current, in the previous, or the total sales in the previous month. Now we want to take a look at the month prior to that. Okay, so here we use the same expression, except when we do this date trunc part, we're not going to look at the previous month. We're not going to look at -1. We're going to look at -2. We're going to look 2 months back. And once again, if the first of that month equals the first of the order date, then sales. And we've got those two values, and then the month over month is just very simply a month over month calculation. We just take the difference between these two. And I'm picking just an absolute difference so you can see that these numbers do actually total. But the important part here in using the LOD is to understand that the conditional statement is embedded in the LOD expression. It's not outside the LOD expression. Okay, well, we've been working pretty much with if-then statements. Let's take a look at some things you can do with a case statement. And we're going to come back and first look at a case statement based on a measure. And what I want to do with this case statement is take you through some logic that's built here and show you the syntax of the case statement. Case statement looks like this. It starts out with a keyword case, and then there's a condition. This is a condition that is used in the test, and it forms the first half of the test, if you will. This condition says, well, if the minimum segment, and you don't see an equal sign, so well, what's going on? Well, when the minimum segment, that's the when here, when the minimum segment equals consumer, then sum sales. Okay, now to show you what the difference is here, when the minimum segment equals corporate, then sum the quantity. And when the minimum segment equals Home Depot, I'm sorry, home office, then sum the sales divided by the sum of the quantity. So we're going to take a look at different measures based on testing what segment the record is in. And I've got three segments here. We've got the consumer segment, we've got the corporate segment, and we've got the home office segment. Now, a couple of things are happening that you have to understand. First of all, case statements work with equalities. They work with they're actually calculating a Boolean, but that's a little too deep for an engineer like myself. They work with equalities. The statement for case has to be true when it reads that value. It could be a numeric value, it could be a string, but it has to be equal. It can't be less than or equal to, or greater than or equal to. It has to be equal to. Okay. And when that condition is met, then the then clause is executed. And just like before, if it's not met, Tableau goes on to the next statement, and we're not using an else if statement here. It goes on to the next when statement. So if the record does not equal consumer, but it does equal corporate, then sum the quantity. And if that's not true, when the segment equals home office, then sales divided by some quantity. Now, the other thing that you have to know here is I've aggregated the dimensions here. I've aggregated this by using sum sales, and I've used sum sales divided by sum quantity. Once you do that, the entire expression has to be aggregated to the same level. And you've gotten aggregation errors before, you've been frustrated by them. And that's why we're looking at the min segment here. I could have used ATTR attribute also, but I try to avoid using that whenever possible. I use min or max when I can. So let's just see what this thing does. So I've got this case statement, and we're going to take a look at this first record. I've got the consumer segment, and I've just included in this chart here, I've included the sales and I included the quantity so that we can see what in this third column over here, fourth column over here, is the actual execution of the case statement. So it says when it's consumer, sum the sales. So here's consumer, and these are the sales, and sure enough, these values equal those values. When it's corporate, sum the quantity. And then come across here, well, it's not sales. These are the quantity, and those sure enough are the quantity values. And when it's home office, then I want to take the sales divided by the quantity, and we're taking that value divided by that value returns this value. So that's the basics of a case statement and how to use a case statement. Well, there's a lot of things you can do with case statements and with if statements. One of the things you can do with them is we can we can use them in conjunction with other features in Tableau. And one of the things I like to do is I like to use them with parameters, for example. And here I've got a parameter where we're going to uh, use this. Okay, I've created this parameter, and this parameter just looks individually at sales, profit, and quantity. And all I've done is I've displayed this as sales, profit, and quantity, and I'm going to return a string, created a string parameter, and I'm going to return the same value, sales, profit, and quantity. I like to do that. Some people like to use numeric values. So the value is 1 and it displays as sales. Value is 2, it displays as profit. I like to use the same value for the display and for the value because I'm pretty forgetful. When I come back in 6 months and I open this book up and I'm trying to figure out what I did, it's a whole lot easier if I can just read what I did rather than having to translate it. So I've created this parameters to select the measure, and then I have this. I've got this case statement. Okay. And when this parameter, and you can see the parameter name is right here, when select parameter, when it's equal to sales, then some sales, when it's equal to quantity, some quantity, when it's equal to profit, some profit. Okay. So now when I change this value, we're now looking at sales, we're now looking at quantity, or we're looking at profit. Pretty straightforward, uh, very easy to use. Well, we can also use a case statement within an LOD, for example. And in this case statement, I am using a case statement to create buckets, if you will. Get a lot of questions out on the forum about doing either a histogram or creating custom bins, or how can I put records into buckets and then look at the data defined in buckets. And the question usually starts out as I tried using groups and I can't get grouping to work right. What do I do? Well, this is a way that you can do it. I want to take a look. We're going to take a look at this statement right here. And this is an LOD expression, and that's part of why I wanted to show you this. Show you how to use an LOD expression embedded in a case statement. And I can take this expression, keyword is case again, and then I write my calculated field. And I wrote this as an LOD expression. You can do this outside an LOD expression also. But all we're doing is we're looking at the customer name and the year of order date, and I'm counting the order IDs. I'm counting how many orders each customer had in each year. And for the intersection of that, I have now another layer in my data set, which we'll talk about when we talk about LODs, another layer in my data set where I've got all that data. And when that value equals 1, that individual is a one-time buyer. When that value is 2, you see this is a value now. These are returning numbers. When that value is a 2, then he's a 2-time buyer. And when the value is a 3, he's a 3-time buyer. Okay? And anything else, just lump them together and call them a frequent buyer. So now I can use this expression, and I've used it here as a dimension, and you can see this automatically creates a dimension. But I've created this as a dimension, and I can place that dimension up on columns, and you can see I've got individual columns for 1-time, 2-time, 3-time buyer, and frequent buyer. And I can place the year of order date on rows, and all I have to do is count the customers and can drop those customers in on the year of order date, and we know how many customers bought in each period. Pretty easily done, but what I wanted to show you today is how you use an LOD expression inside a case statement. Okay. We can also use this to do stuff like comparing values. I've got a statement here where I took the regions, and we know there's 4 regions in Superstore data. There's the East region, the West region, and the Central region and the South region. And I wrote a case statement, and I said, okay, when the region, case region, when it equals East, I want to call that coastal. And when it equals West, I want to call it coastal. And anything else, I want to just call it middle. So I've taken those 4 regions and I've broken them down to 2. And all the records in my data now are labeled either with coastal or middle. They still have East, West, Central, and South coded in their region. But we have this other dimension out there called manually created sets and groups that is either coastal or it's middle. So I can take those and I can use that like I use any other dimension, and I drop it onto my rows, and I've got 2 categories here, coastal and middle. I've got my segments, consumer, corporate, and home office. And all I've done here is drop sales on it. I've used a very simple, I've used just a percent of total calculation going across to break out our sales uh, by shipment in those regions. And if I wanted to take out the segment, I could take out the segment, and we still see overall how those shipments broke out in the coastal region versus the middle region. Very easy to do using a case statement. Now, I want to take a look at using once again using or statements and using and statements. And I think the easiest way to do it is look at this piece of data right here. Created a scatter plot. And in the scatter plot, and if you're not familiar with scatter plots are a great way to look at a disaggregated level where your data lines up against 2 different measures. And in this case, we're looking at the sum of sales and the sum of profit. And then I've taken each we're looking at the state level. I've taken each state and I've broken that data down by state. And what I'd like to do, looking at this data, is I'd like to start by identifying those states where the sum of sales is greater than 10,000 or the sum of profit is less than 0. So we're looking at areas, at states where the profit is negative or the sum of sales is greater than 10,000. Now, I want to go and look again at this statement. Okay, it's the same statement, except I'm looking with the and conjunction. Okay? I'm looking at where the sum of sales is greater than 10,000 and also the sum of profit is less than 0. So I want to look at the and option on that. And when I look at them at the same time, I put them on the dashboard against one another. We can get a better understanding of how or and works. This is the or scatter plot. Okay, these states either have negative profit or they have sales greater than 10,000. This plot has sales greater than 10,000 and the profitability is negative. So you can see you can use or you can use and. I want to move on to one different type of condition we look at, and that's the in statement. And the in statement is something that actually was relatively recently added into Tableau. Some of you may be familiar with this from SQL. I don't write SQL, so I really can't speak to that. But the in statement would look something like this. This is just where we're looking at state or province. I says, if in the in statement here is embodied inside an if-then statement, okay? If state or province is in, and here I've got three states that we're looking at, Ohio, Indiana, and New York, then sales. And what this will do is to look at each record and it'll look at the state dimension on the record. And if it is Ohio, Indiana, or New York, then it's going to capture the sales. If it's anything else, it's going to return a null. Okay. And just very simply, we can look at that. And you can see here, I've got, this is that statement we just looked at. And I'm looking at state or province there. And we're looking at everything that is in that category. So we got Indiana, New York, and Ohio. Okay. We can use that same statement to do some other things too. This is a way. Every so often we'll get someone to say, Tableau does a real good job of breaking down uh, calendar dates. I can look at years. I can look at months. Uh, I can look at days. I can do year-over-year analysis. But in our organization, we look at half years. And I'm going to look at the first half of the year versus the second half of the year. So I can do that with a case statement, and I can include the in statement inside. I can embed it inside the case statement. So I'm going to take a look at a case statement, and here in the case, we're going to look at the month of the order date. And when, and here's where we use the in statement, when in 1, 2, 3, 4, 5, 6, can't use 6 or less. I can't use when 6 or less than first half. That will not work. But you can use this statement when it's in 1, 2, 3, 4, 5, or 6, then it's the first half. When it's in 7, 8, 9, 10, 11, 12, it's in the second half. And by doing that, we're able to create first half numbers versus second half numbers. And I just plotted them against region. Region doesn't have to be in there. You could just pull that out. And you could have 2 bars in the chart. But I thought it was a little more dramatic to have more bars in the chart. We can do this one final piece here. We can take the same type of analysis and now I've used a LOD expression in the case statement like we did a couple of examples ago. I've used when the product name in category, fix it at the combination of product name and category and count the order IDs, count the number of orders. And when that's 1, 2, or 3, that's infrequently sold. When it's 4, 5, and 6, that's average sales frequency. These are just arbitrary boundaries or arbitrary buckets that I've set up. And then if it's anything else, here we can use the else part of the case statement also. Else, it's frequently sold. So I've got 3 buckets. I've got infrequently sold, I've got average sales frequency, and I've got frequently sold. And I've created those buckets by combining a case statement and using an in statement embedded in a case statement. And that's those values here, infrequently sold, average sales, and frequently sold, and by category. And I've dropped in the count of the order date so that you can look and see how the count of the order date varies by category versus frequently sold or infrequently sold. Okay, just a couple more things to look at. And this one is kind of really cool because we get questions all the time about calculating the top end in others. And how can you go about calculating the top end in others? And there's several different ways of doing it. And if you've ever read some of my blogs, I've got some pretty involved and pretty complex ways of doing it. Sometimes those are needed, but this is one that works, and it works very well also, and it's pretty easy to do. First, I set up a parameter, and this parameter is nothing more than an integer parameter. Okay, I set it up as a floating point parameter, but and I set a value in it, and I set the value equal to 4, just for examples here. And then I've got this category, I've got this, and this is an example of how to use not. And if not subcategory in the subcategory set, I've got to show you the subcategory set first. Let's look at the subcategory set first. We're going to edit the set, and the set itself is just a set to the top end, and that's set by the parameter. So right now it's sitting at the value of 4. And now we've got to take a look at this. And this is an example of using not. If the subcategory isn't in the subset, the set of subcategories that we created with the top end, if it's not in the top 4, then it's other. If it is in the top 4, so if this is true, and this is double negatives, if you will, if it's not in the top n, then call it other. If it is in the top n, then it's the subcategory. So we've created, by using that statement, by using the labels in that statement, we're now going to look at labels on the subcategories, and we've also got the other category, and we're able to total them, and we know what the total profit, quantity, and sales are. And we can change that value dynamically, if you will. You say, I only want to see 3 in the top 3, and you can change that value to what you want it to be. It's pretty easy to do. Explaining it is kind of difficult because you get this double negative thing. You can calculate what's in the set, but I want to calculate what's not in the set and call it other, and then everything that's in the set, I want to use the category name. And this is just that same example. And what we're looking at with this example is I've just done a ranking with that. And we can take a look here. We can, I've got this is just a fixed region subcategory sales. So for each region and each subcategory, total the sales and save that as a fixed value. I can then take that and I can rank that uniquely. Okay, we have a ranking at the region and the subcategory level. And I use that same idea of creating that subset using this parameter to see as many as we want. And I use this statement. This is now, if not subcategory in, this is the same type of statement I just showed you. If it's not in the top n subcategories, call it other. Otherwise, that's the category. That puts these labels in place. And then we can just do a true false on that if the ranking is less than the top n, or this is true, it's one of the category, or the category equals other, then we want to see it. Okay, and that's what we've done here. And we can see that this is controlled by that parameter again, and we can look at this as 4, and we can expand it. So now we're looking at the top 4, we're looking at the top 4 by others. And it's kind of interesting to note that, let's see if we've got a good example. You'll see here in Central, our categories are other. They are chairs, phones, and storage. And here in the South, our categories are other, chairs, phones, and tables, not storage. So we have calculated the top n and others unique by region. And that's all done dynamically. And I've got one last item to show you. We can do this based on running sales also. I've got here, this is the window sum, and I've created this if-then statement embedded in a table calculation. Now, you remember before when we started using LOD expressions, I said you take the if-then and you embed it in the LOD expression itself. You don't put it outside the LOD expression. The same is true for table calculation. You can create a table calculation, and here I'm just using a window sum, but I only want the condition if the category equals furniture, then sales, end, and I want to sum that. So I'm only looking at furniture sales, and the window sum going first to last will create a running total. Okay, and that's the values that you see here, and these values are for the furniture category only. These values here are the total sales. So you see furniture represented some percent of the total sales. And we can come back and we can take a look at, and what I've done here, just to show you we could do it, is I've taken that same idea and I've taken if the category equals furniture, calculate the running sales over the total running sales, the total bottom line running sales. So we can look at the grand total. Furniture represents 32.4% of sales. And if we look down by category, by each one of these, you can see that you can see all those values total. Okay. I want to thank you very much. I hope you have a better understanding of the options that are available using if statements, case statements, and in statements, and using their negative not in statements also. It's a fundamental part. It's something you really have to understand how to use when you start using calculations, because we use them all the time. And the only way you're going to get better with Tableau is by using it, by practicing it. So I encourage you to make up your own examples, and use some of the examples that you've seen here, or you can go out to my blog at jimdehner.com and you can download the workbook associated with this. It's a workbook that's by the same name, or you can see the blog by the same name, and there is a workbook associated with that, and the link for that particular workbook is built into the blog. Very good. I thank you for your time, and we'll see you next time. Bye now.